This is one of my favorite problems to do here because I just give you a pretty straightforward polynomial. It's a quartic. We're going to use this definition here for a, this is the Taylor definition. We're going to do a Maclaurin at x equals 0. And hopefully you'll see that I can, using this definition here, I can really just create this thing again. It's kind of circular. So it's a nice little exercise here. So here is my function. My derivative of x is 4x cubed minus 9x squared plus 2. My second derivative of x is 12x squared minus 18x. My third derivative of x is 24x minus 18. My fourth derivative of x is 24. And notice my fifth degree goes away, right? Fifth derivative goes away. So let's just do f of 0 while we're here. If I plug in f of 0, I get negative 4. F prime of 0, the x's go away, I'm just left with 2. F prime of 0 is 0. The third derivative at 0 is negative 18. The fourth derivative of 0 is 24. Hopefully you'll see where I'm getting at this in a second. So using this definition here, my fourth degree polynomial, f of 0 we decided is negative 4, plus my first derivative at 0 is 2, so it's 2 over 1 factorial x minus 0, to the first, plus the second derivative is 0 over 2 factorial x minus 0 squared, that's a squared. My third derivative is 18, 3 factorial, x minus 0 cubed, and my last term is 24 over 4 factorial, x minus 0 to the fourth. So my fourth degree Taylor approximation of a polynomial. Okay, this is really, I've just made a Taylor polynomial. I'm trying to use a polynomial to approximate a polynomial. Seems kind of silly. Yes, you'll see why in a second. So negative 4, this is just 2 over 1 factorial and x minus 0, so this is just really just plus 2x. This term goes away because the derivative is 0. 3 factorial is 6, so 18 over 6 is 3, so this is minus 3x cubed, and this is 4 factorial is 24, so 24 over 4 factorial is 1, so this is just plus x to the fourth. And if you take this and look at this, you should go, oh, wow. That makes sense, that it actually works. If you want to approximate a polynomial with a polynomial, that way Taylor polynomial, you should get the same exact thing. The purpose behind this thing here is e to the x is kind of an ugly function. It's called a transcendental function. How does a calculator or a computer approximate what e to the x is equal to? It writes it as a polynomial. And then does this quick little calculation here. If anybody's in computer science, this should feel like a real for loop to you for here, that you should be able to calculate this quite easily. Well, at some time, your calculator did the same exact formula here. They do a little better formula now, but early days of calculators, that's what they used. Okay, so what did Taylor polynomials do? And they're just taking funky functions, crazy functions, and writing them as polynomials because polynomials are easier to calculate. All right, there you go. That's from me to you.